This is the Pearson Edexcel AS Core Pure Maths Paper 1 from November 2021, so just based on the first book of the Core Pure books only. Let's just go straight into it. It's 80 marks, it's 10 minutes longer than the original paper. Anyway, so when you're doing transformations with matrices, you can obviously look in the formula book, you'll see this help. This could be helpful to you if you happen to just sort of spot that to make cos of theta 0, you could use, of course, cos of 90. And that also makes sine of 90 1, which is good, and minus 1 here. So therefore, this must be a rotation 90 degrees anti-clockwise about O. So that's cool. You could also, by the way, kind of notice that. In fact, I'll do this on the other one. So let's say that we don't know what this transformation is off the top of our heads, and it doesn't seem like this is going to be very helpful, because of course this is too big. Just try some points, right? Just take the point 1, 0. That goes to there. Of course, 1 times 1 is 1. Plus 0 times 0, and then 0, and then 0, cool. So 1, 0 doesn't change, doesn't move anywhere. What about 0, 1? Well, that does actually move. That goes to 0, 3. So 0, 1 stretches out factor 3 to 0, 3. So what transformation is doing this? Well, one more will give you a good idea as well. 1, 1 goes to 1, 3. So like something here goes to something there. This is a stretch factor 3 parallel to the y-axis. Right, so if you already don't have anything in the y-axis like 1, 0, it doesn't stretch it because 0 times 3 is still 0. But it's a stretch parallel to the y-axis factor 3. So try some points out. If you're ever a little bit unsure, you could have done the same thing for this. This will just rotate them around this way, as I said. So yeah, just try stuff out if you're a little bit unsure. Transformation P is followed by the transformation Q. So let's just get the order right here. P acts on a coordinate xy first, then Q acts on the result. So it goes in this order. P here, then Q. You don't just go left to right. So okay, now we just need to multiply these together, so I think those make this. 1 times 0 plus 1 times 0 is 0. That makes minus 1 plus 0, 0 plus 3, and then 0 and 0. So I think that's R. Evaluate the determinant of R, so that's going to be 0 times 0 minus 1 times 3. I think that's 3. So that's good. And then explain how the value relates to transformation. The determinant of a matrix that's being used for transformation is the area scale factor. So you can just write that out. Good. Question number 2. So we say, okay, let's let w equal 3x minus 2. Rearrange that for w plus 2 over 3 equals x. And just put that entire result into here. I think I've times everything here by at least 9. I can't quite remember. So yeah, when you cube this, you cube the top and the bottom separately and square the top and bottom separately, which is what I did here. But I don't like these fractions, so I think I'm going to times everything by, what have I done, 9? I think I've times everything by, because that makes a third. So times by 9 makes 3. This times by 9 just gets rid of that. That times by 9, or that makes a, sorry, yeah, that's 4 thirds times 9. The 3's cancel with another 3, and you get 4 times 3 is 12. And then that times by 9 is that. And then, of course, we've just got some binomial expansion to do. We'll expand everything else out. We just won't make a mistake because we don't want to make a mistake on questions like this, and we'll eventually get the answer. So we've got standard results. As soon as we read that, we look for what the standard results are. There they are, that's what the formula gives you. Let's expand this out. I think it makes that. If you expand it 5r times 5r, then you've got 2 cross terms, then minus 2 times minus 2. Of course, we can break this into 3, and we can also put the constants out the front to make this. So break it here, put the 20 and the 25 at the front. This we can also say is 4 times 1 and just put it there. Now this is a standard result that's in there. We're allowed to use the standard results. We don't have results for these two. You're just expected to know that this one is n into n plus 1 over 2 and this one is just n. So those are the results you're just expected to know. Now we're trying to sort out this. So it wants me to put a n on the outside. It also wants me to put a sixth on the outside. So let's do that. We can see that there's an n in every term to factorize out fine. That's good. Let's also just bring the 1/6 out because they want us to. So what I'm going to do is I'm going to swap the 1/6 and the 25 from there, and that allows me to take 1/6 out really easily. And then here, I mean, that makes a 10, 20 over 2. So if I take a sixth out, I need a 60 there because 60 times a sixth is 10, so that works. And this times 1/6 n times 24, I think is 4n, so that works as well. Now everything in here just makes a quadratic, and I'm perfectly happy to expand out a quadratic, partly because I see a quadratic there, but also even if it wanted me to factorize it afterwards, I'm happy factorizing quadratics. So yeah, just expand everything out, tidy it up, and you get your answer. Good. Hence determine this. Now just look really carefully. They often like to give you something that doesn't start at 1 or something that doesn't finish at k. Here, I think we see an example of that later on. But this time it's fine, it's just the result here with a k there, so we put a k into there, and that will be our result there, and we just say that equals that. And now I think I times everything by, no, sorry, I divided everything by k here because k is not allowed to be anything other than a positive integer. I times everything by 6 as well to make this. I moved that over. Now here's a nice little challenge. K has to be a positive integer, right? Which means this must factorize. Can you spot it? I mean, just put it in the calculator if you don't want to play this game, but sometimes it's nice to just try and do this on your own. It's actually not hard to do this. It's the easiest one, I think, because it's just obviously 11 times 1. The first thing you'll try is maybe just putting a 50 and a 1 down for the other two, and that actually just works. So yeah, we have the answers of minus 1 over 50, which obviously can't be the case, or 11, and we'll take the answer of 11. And good, that's question number 3. Question number 4, quite a nice question here. Deduce m times n. This just takes a lot of work. It's quite a lot of work for 2 marks, to be honest. Just be very careful. So like this term, for instance, is 2 times this, which is 2k minus 14, plus 2 minus 12, which I think is this. And then this term is 2 times 6 is this first row times the second column to make this. So 2 times 6 is 12, minus 20 plus 8, I think makes 0. And then this one is going to be 2 times minus 10 is minus 20. Plus 24 is 4, and then minus 4 is 0. And just keep going on that vein, and you get all of this eventually. Given that k is 5, so okay, write down mn, so we just substitute 5 into there. That's not tricky at all. Something interesting happens, obviously, which I think is what they want you to use. This is the same as minus 14 times the identity, because if you just put a minus 14 there, that would just be 1, 1, 1, everything else would still be 0. So it's just minus 14 times the identity, and that's how they want you to do m inverse, right? They want you to notice that m times n is essentially the identity, so therefore n is the inverse of m. Now it's not quite because of this minus 14, but you can just slightly rearrange that to say that the inverse is going to be minus a 14th of n. So you just use this factor in the front. If you just substitute in k as 5 into n and put the minus 14th out the outside, you'll get the answer there. Solve the simultaneous equations this. Now notice that all of these coefficients just perfectly make the matrix M as long as k is 5, which we've already dealt with. So we put k as 5 into there, and we have this, x, y, z, and then these are the answers. Now, of course, to solve this, you just times, on the front, times by the inverse of m, which we already know to be that, so we'll get this. And then you can actually just put this in the calculator to get the answer there. So just put that in a calculator and you'll have your answer. The other way, of course, you can check this is you can put this times this in a calculator. Sorry, not this times this. You can put m times this in a calculator and make sure you get the identity where k is 5, of course, just to double check that. But yeah, you can do lots of this with one. Interpret this is where the 3 planes meet. Obviously, it always is. That's always the answer. Good. Question number 5. This line shouldn't have appeared yet. We'll ignore it for now. I don't know why I didn't put that in properly, but we've got a set of points. So the shaded region, ignore the line. The shaded region is this set here. Now, this isn't written correctly. This should be z minus some complex number. But okay, this has got a center clearly minus 2 plus 1 I. And it's got, the first circle has radius 1 and the second circle has radius 2. So I'm pretty comfortable with saying that A is 1 and D is 2. And then, like I said, this should be written as Z minus brackets minus 2 plus I. And if we expand that out, we get Z plus 2 minus I. And so therefore B is 2 and C is minus 1, I think. And those will be all of our results there. Q is defined by the same circle, or the same, I should say, donut, really. And all the complex numbers such that you're closer to I than you are to 3i. And that's what this means. The distance from your complex number to the number I is less than the distance from the complex number to 3i. So therefore we have a horizontal line across here. And like this number is closer to I than 3i, and so is this number. But like stuff up here isn't, so we need to be below this line here, which is what I was meant to bring up at this point. But that's okay, and now we need to find the exact area of everything in the shaded region below this line, so just this bit here. And this is not the easiest thing to do ever, but they have asked a very similar question to this in the past, so that's kind of how I did it, was just remembering that solution. If you draw a line out from here to here, that's clearly got distance 2, this clearly has distance 1, and so theta, I mean, you can just do some Pythagoras actually. You can do 2 squared minus 1 squared is rooted as root 3. And then you can probably recognize this triangle, right? Cos of 1 over 2, cos theta of 1 over 2, what theta do you need? Well, you need pi over 3, right? So this is pi over 3, which otherwise you could do this in degrees, it's 60 degrees. And then, of course, I can double that out to get this one, because these two triangles are the same, obviously. So this is 2 pi over 3. And now, of course, to work out this area on the top, because my plan is to work out the area of the entire donut, and then just take away this area on the top. But to work out this area of the top, it's just a segment. I can just do this whole sector minus this triangle in here. So the sector is r squared theta over 2 if I'm working in radians, which is just good practice too, I guess. Theta is 2 pi over 3, r is 2, clearly, and over 2, that's just radius there. And then we've got this triangle here, which is a half AB sine C. A and B are both 2, and C is this angle again there. So we put all that in, we sort it all out, we get this, and then yeah, we just say, okay, what's the area of the donut? Well, it's clearly pi times 2 squared is the whole thing, minus pi times 1 squared, that's 4 pi minus pi. And then we take those away for 3 pi, and we just do 3 pi minus this for our answer, which I believe is 5 pi over 3 plus root 3, because minus minus, and we have our answer. Excellent, not the easiest question ever, but good. Let's do a planes question then. This question is quite interesting as well, particularly towards the end. So we have 3 points that are in this plane here, which is the mineral layer model thing. And we want the equation of the plane as r dot n. Now, the first thing we should do is find a vector from a to b and a vector from a to c. So to get to a to b, we add 5 in the x's, add 25 in the y's, add 5 in the z's. And from a to c, we take away 15. We take away 15 again. Sorry, we add 15 from there to there, don't we? And then we take away 10 there. So that's that. And now if you've done FP1, if you're doing ASFP1, you probably know that you can just cross product these together to find a normal vector, which will be this vector n. Now if you don't know that, there is a way to do it anyway. You just say, you sort of let n be a, b, c. And what you're looking for is, you're looking for a vector, like I said, that's perpendicular to both of these vectors that live in the plane. So we want a vector that's perpendicular to both these. Now, you can use dot product here because the dot product of any two perpendicular vectors is 0. So therefore, this dot this is 0, and this dot this is 0. And of course, we can actually do this, 5a plus 25b plus 5c, and then this one here as well. And this is a simultaneous equation, right? Except it's a simultaneous equation with too many unknowns, which is usually a bad thing because it means you can't solve for it. But it's actually okay because all I can do is I can just say, well, let's just let a equal 1. Right, we've got a degree of freedom here because there's too many unknowns. Let's just let a equal 1 and make these two simultaneous equations and solve these for b and c. You can let a be anything you like, except don't make a 0, because if you let a 0, you're just going to get 0, 0, 0, and that's not very helpful. Almost all the time anyway. So yeah, let's just let a equal 1, and then we'll solve these two. Of course, if we double this and add them together, I think is what I did this. Yeah, so I doubled this one, added them together to get this. So b is that. And then of course I can substitute in to find c, eventually I'll get this. So the normal vector I can say is 1, 1/13 minus 18 over 13. Except that's not going to be a very fun vector to use. So I'm just going to times the entire vector by 13, because of course that doesn't actually change its direction or anything. And I think this will be a much more fun vector to use for these questions. So I think my answer is r dot this equals d. Now that's not the actual answer because I need to find d. So we just take one of the points that's in the plane, we put it into R, and we can dot product out, and we'll find D. And we'll find D is this, and so this will be the answer to the first part. Again, if you know cross product, you can do that a bit quicker from FP1. Good. Determine according to the model the acute angle between the ground, which is a horizontal plane, equation z equals 0, and the mineral layer. So we're looking for the angle between two planes. Now, this is technically Cartesian form because you can write it like this. And then if you want to, you could write it like this. This is r dot 0, 0, 1 equals 0, isn't it? So that's the equation of this plane. And we already know the equation of this plane is this. So here's, let's just say that this is the mineral layer plane, which has a normal vector of that. So we've got a vector coming out perpendicular, which is this. And we've also got this, I'm just saying this is the ground. So we're looking at the planes from above. So they look like lines, but it's just because I'm looking at them directly above. We have a normal vector coming out of the mineral layer like this, which is this vector. And this is the ground, which has this normal vector coming out of it. So if I dot product the two normal vectors together and do the cos theta equals dot product over magnitude thing, I'll find this angle here. And then, of course, I can do 360, take away, take away, take away, and I'll find the angle between the two planes. So let's do that. So let's dot together the two normal vectors, and then this is 13 squared plus 1 squared plus 18 squared. This is, of course, 0 squared plus 0 squared plus 1 squared. This is just from the formula book, I believe. I think it's in the formula book. I'll double check afterwards. Anyway, that, of course, makes this 0, 0 minus 18. Do cos inverse of that, we get this. That's this angle. So now I can just do 360 minus all the others, and I'll find alpha, which is roughly, to the nearest degree, 36. The mining company plans to drill vertically downwards. Now this question is really interesting because it's really tempting to just break out the formula here that's in the formula book for a distance between a point and a plane. But actually, you can't do that. By the way, you could have, I was going to mention this, sorry. If you put the magnitude outside of the cos thing and therefore say this is plus 18, you'll just get the answer. But I quite like to do it like this just because I like to show where the result comes from. But yeah, if you put the magnitude there, you'll just get straight to the answer. So you're welcome to do that. But I always like to picture it like this just to make absolutely sure that I am going to get it right. But anyway, it's up to you. So we have this point here and we have the mineral layer there, which is this this plane here. Now we have to drill vertically downwards, so we're not actually going to go to the plane in the shortest route possible, which is what the formula does. We're going to drill vertically downwards, and what that means is the only component of this that's allowed to change is this one here. Right? If you drill 1 downwards, you get to 5, 12, minus 1, and so on. So when we meet the plane, we're going to be in a coordinate that looks a bit like this, right? Because this is the only coordinate that's allowed to change. Okay, and this is very straightforward as soon as you make this realization and don't just go the quickest journey possible that's perpendicular. Just put 512k into here and find what k needs to be. Do the dot product out, and we'll get this, which is this, and we'll get k as the answer of that. Of course, k being negative here means it's a drop of 53 downwards, but of course the distance is just that number, 53. State the assumption. I mean, mineral layers probably aren't perfectly flat like planes need to be, so that's my assumption there. Question number 7. I think we've only got 2 left. This one's quite a nice one. Of course, if you've got a root 2 plus I, you've got another root of 2 minus I. You can just get that for free, so I'll call that one gamma. Explain why delta must be real. Well, if delta was complex, it would have to have a complex conjugate, and I already know 3 of the roots. And one of them's real, and the other 2 are their own conjugates. So there's no extra room for delta to have its own conjugate pair next to it. So it has to be real, and it can't be complex. Good. Determine the value of delta. So there's a few ways to do this, but the easiest way is to use this 6 here. The sum of all of the roots equals minus 6 over 1, because they're individual roots. It's going to be a minus here, and then minus 6 over 1, which of course just makes 6. We know 3 of the roots, so we get delta as minus 1 quite quickly. Good, so now we know all 4 roots, and again, there's lots of ways to work out p, q, and r, but probably the quickest is to just put f of z in factored form with all of the roots that we know in here. So this is the root 3, this is the root minus 1, and these are the other 2 roots. And now expanding out this is very easy. Expanding out this a little bit more tricky, but hopefully you've practiced stuff like that before. You can verify that it's this, and then of course expand these 2 out as well. You get this, simplify it up, we get this. And so therefore p is 10, q is 2, and r is minus 15. Probably the easiest way of doing that. This question as well, probably easiest to do factored form again. So we know factored form is this, I just wrote that down. And now just replace z with minus 2z, like this. And now the roots of this are just what solves each of these brackets. So like to solve this bracket, plus 3 divided by minus 2, z is minus 3 over 2. To solve this bracket, minus 1 divided by minus 2, z is plus a half. And likewise solve this one, and we get those 4 roots there. I think this is, no, there are 9 questions I remember, because there is an integration question at the end. So proof by induction here, z equals 1. Sorry, n equals 1, let n equal 1, so we're just summing up to 1 here, so we just put 1 in here, and that's the entire thing. That equals 6, 1 times 2 times 3, which technically, if you replace 1 with all of these, you can verify that that's also equal to 6, right? 1 times 4 times 3 divided by 2 is the same as 2 times 3, so that's therefore 6. Good. So it's true for n equals 1. Assume that it's true for n equals k, where k is an integer. So assume that this thing is true. Assume that up to k, this equals that. Now let's investigate k plus 1 by doing this. Now this is a very standard job here. We split this sum into going up to k, so we can use the assumption step, and then just plus the last term on its own. Now this, according to the assumption step, is that, so I'll put that in. And this, just replace all of these with k plus 1s, because that's the only thing that's going on here. And we get all of this. And now we can factor some stuff out here, I think. We can factor out a k plus 1, can we? Yeah, because there's one there as well. We can also factorize out a half, I guess. I think I'm going to do that in a second, though, actually. First, I tidied up all of these things, it looks like, which is probably sensible. Factorize out the k plus 1 here. Factorize out the half. Also factorize out the k plus 2, you can notice. So all you leave behind here is the k and the other k plus 1. And here, use a 2 to cancel with that half there. And then all you leave behind is 2k plus 3. I think I just expanded this out now. I did, and then this is 5k in the middle, so that factors to this, which, just to be really careful, you can write, obviously this is k plus 2 squared, but you can write that as k plus 1 plus 1, and this is k plus 1 plus 2, and that makes it perfectly in this form, I think, where n has been replaced with k plus 1, just to be super clear, and therefore, if it ever works for n equals k, then it's definitely true for n equals k plus 1, and we know it was true for n equals 1, therefore it's true for all positive n's. Good. B, so yeah, this is what I was mentioning earlier. We can't just use this result here because it starts at n. So okay, the sum from n to 2n, so imagine this as being the sum from 10 to 20 terms. The sum from the first, from the 10th to the 20th term is the same as the sum from the 1st to the 20th term. Take away the sum from the 1st to the 9th term, right? That will leave me with just the sum from, say, the 10th to the 20th. So I think this works here. Of course, I can use the formula on this, just replace these with 2n's. I can use the formula on this, replace these with n minus 1's. Let's put those in. Simplify some of this stuff up. I think I'm going to cancel this 2 with this 2, but then factorize out a 2 from there to make n plus 1. So I think that's what I've done there. I think that all works. And then here, this is just n squared, because they cancel, and this is n plus 1 there. Now factorize out some stuff, factorize out an n, factorize out an n plus 1 to make this. Also factorize out half, I guess, because it says that I should probably do that. So that makes a 4 here with those two terms left over, and then this goes away because it's there. This reduces by 1 and just left with this. Again, expand this out because it's just going to be a quadratic, so I'm not very concerned about it. Expand this out, 2n plus 1 times 2n plus 1 is 4n squared plus 4n plus 1. Expand that out from minus n squared plus n at the end there. Times the 4 through, collect all this together, and just hope and pray that it factorizes, which it does, I hope. 15 plus 12 plus 5, yeah, and then plus 4, perfect, and we'll have our answer. Notice how you can't actually determine A, B, C, and D because you could choose which bracket you'd like to be which ones. I wrote them out the way that I had them, but it doesn't really matter. So yeah. Good. Question number 9 then. Apologies for making this so small, just did want to fit it onto one page. I think you can just about read this though. We've got a curve here which is modeling a candle. You're going to rotate it around the y-axis to kind of model that when you integrate, so that's fine. We've got equation BC is this, and the first bit is find A. Now we know BC goes through 3, 0, but that's not very helpful, I don't think, because when you put 3 in here you just get 0 on the top, which makes y 0, and you don't solve for A. So instead you put this point in, you put in x is 5, y is 15. You put that in there and you will solve for A. If you do this, the root of that is 60, of course, so A is 4. So that's the equation of this bit. And then the equation of this bit, it later says C to D is this. And we want to use some integration to find the volume of the candle. So okay, we split this across here and we say, okay, let's integrate this curve around the y-axis between 0 and this is 15, isn't it? So let's integrate that. It's going to be around the y-axis, so it's x squared dy. So I'm going to have to rearrange that for x squared, which shouldn't be too hard. Times it by 4, square everything. Add 2025, divide by 225, we get this. I can put that in here. I'm going to just divide by 225 out here, just because I don't want to deal with it in there, so that's fine. And then this one here is the integral between 15, and now where's this point? Well, x is 0 when you're here, so put 0 into there and you get y is 16. So this is 16, so it's going to be the integral from 15 to 16, of course pi outside as well, of this curve, again x squared dy, rearrange this, so it's going to be 16 minus y is this. Divide by 0.04, we get that, and we can put that in as well. And we just have some integration to do, so not too bad. I'm going to go through it very quickly, just double check all my working if you want to. But you just integrate in the standard way, you put the numbers in the standard way, you shove it all into a calculator and you'll get this answer, which is this. So this stuff turns into that, and then this all turns into that, and we get this. Good. So that's the 9 marks. Data limitation of the model. I mean, this is an answer you can give every single time. It's tempting to actually think about the candle like, oh, there's going to be wick going through the middle that reduces the volume. You can literally write this sentence every single time if you'd prefer, so maybe just do that. When the candle was manufactured, 700 centimeters cubed were used. So okay, type this into a calculator and you get this. You're only 15 out or so the model seems pretty good, and you can just say that. Excellent, thank you so much for watching, and I'll see you next time.